Welcome to Impulse, the IFM show. Ships are an integral part of our globalized world. More than 100,000 of them are traveling the world's oceans, moving goods and people between countries and continents. In this episode, we will talk about how automation technology helps to keep the floating backbone of the global economy running reliably and to operate it with a lower environmental impact. So let's get started with my first guest, Christian Kostede. Hi Christian, thanks for joining us today. Shipping is an important pillar of the globalized world, but what importance does this shipping industry has for IFM?
Yeah, the shipping industry is a focus industry at IFM, and we provide sensors and solutions for this industry to help this industry to get the Green Deal.
Okay, perfect. So what kind of expertise does IFM offer for the shipping industry where they can particularly benefit from?
IFM has experience in controllers and displays for harsh environments, and they withstand temperatures from minus 40 degrees up to 80 degrees, also resistant against salt water. That's very important for a ship. And we also have a lot of knowledge in water treatment systems and condition monitoring systems, especially vibration monitoring systems.
Which is important for pumps and engines,
yes,
what we will talk about later on as well. So beside this portfolio and these offerings for the shipping industry, do you see untapped potential where the shipping industry can use automation to improve?
I think the digitalization is an untapped potential for this industry. For example, with IO-Link, you can get more information from a sensor than with a standard sensor, how the condition is of the sensor itself, and you get more information, not only a switching signal, and with this you can get a better overview of the condition of your engines or bearings or valves and pumps, and can see it on one view on a monitor with our software, so that you are aware of your ship the whole time.
Okay, perfect. So let's have a look into the future. What are your plans to develop the portfolio, to expand the portfolio that you're offering for the shipping industry?
Today we have a good portfolio for the marine industry with DNV approval, but we want to expand this portfolio. We will get a conductivity sensor, the LDL 400. This will be used mostly for water treatment system, for example, ballast water treatment system, to get the value of the salt concentration of the water, and that is important to know if you discharge the water, is it salty or not.
Okay. Christian, thank you for this first overview about IFM's view on the shipping industry. And now let's move on to the heart of every ship, the engine room. And let's see what important role automation technology plays there. And here we are in the core of the ship, in the engine room, and with me now is Rizwan. Rizwan, thank you for being here today.
It's a pleasure, Philip.
So Rizwan, you said we need to talk about maintenance strategies, the traditional ones and the modern ones, and maybe we can start with the traditional one. How is it working?
Yeah, well, the traditional methods would just be either run the machine until it stops, or it would actually be using what's called planned maintenance. And planned maintenance would be based on the number of running hours and what the manufacturer would recommend, before any overhaul is carried out. So the overhaul could include things like bearing replacement, lubrication, etc. The problem you tend to find is that with breakdown maintenance, is what's called, being the first one, is that it tends to be a costly procedure. So you end up in the long run you end up paying more for that. It causes downtime. It causes a lot of other inconvenience as well. The other thing about the planned maintenance is that if it's based on the number of running hours, there might be machines that where there's nothing wrong with them, even at those recommended running hours. So it's tend to repairing a machine when it's perfectly healthy. So that could also be costly as well.
So are these also the main problems of this strategy, or are there more problems?
There are more problems because you tend to find that if a machine is being overhauled when it didn't need to, you could also induce other problems to that machine. There could be issues with misalignment after that, and it just tends to kind of go downward spiral. Sometimes, not all the time, but sometimes it can happen. But you generally find that there's optimum, life of that machine gets reduced quite significantly. So that's the main problems, I would say.
Yeah. Okay. So now maybe let's have a look onto the modern ways of monitoring engines and pumps. How is this way? How do we achieve this modern way of monitoring?
Yes, so the modern way would be to get some insight from the machines, using sensors, getting data, being able to analyze that data to determine, the condition of that machine. And it's important to be able to understand or have some kind of an understanding of the condition, so that any action, that is due, could be planned in, and taken care of. So this is part of what's called predictive maintenance. And predictive maintenance will alert any maintenance staff of any change in condition at an early stage. So that then allows them to plan in, maintenance, and it prevents any, failure in service and unplanned downtime. And it improves the reliability of the machine.
And this is what we need, especially when we're talking about ships.
Absolutely.
So this modern way, then we talk about vibration monitoring. What other values do we talk about there?
So the vibration monitoring plays a key role in the whole process. That's because if there is a change in machine condition, it's usually vibration technology that picks up that change at the earliest stage. And then later on, as the wear gradually, builds up, the other technologies fall into place, such as oil analysis, noise, etc. But vibration analysis, as soon as the condition changes, vibration analysis would issue a warning. And that warning is, for the maintenance staff and personnel to be aware that there is something that's changed on this machine, and they should be aware of any or scheduling any change or even remedial work. So vibration monitoring is the main part. What other information can be helpful? The other information that can be helpful, if you're looking at engines, it could be performance, even looking at the power, of the engine. But on an engine, vibration monitoring does play a key role. It allows for any sudden change in the internal components, bearings or pistons or anything on the crankshaft to be detected, at an early stage. And using some of our sensors where we can monitor vibration in 3 different axes. You can pick up from the torsional, axial plane, and even laterally, and issues that arise from resonance, in ships as well. On pumps, you tend to find that you can pick up early problems such as impeller wear, cavitation as well, bearing wear. So even issues with flow or pressure. So pressure sensors, flow sensors on a centrifugal pump, for example, they can really help. They provide more information, more data to analyze, and a bigger insight into the condition.
To sum it up a bit, let's compare the old traditional way and the modern way. What is really the main benefit for the maintenance?
The main benefit would be reliability, failure, prevent failure in service, unplanned downtime. And, on a ship, these could be very expensive in terms of time and costly for money as well. But like being mobile in the middle of the sea, and something fails, it could be quite hectic, and so the other benefit really is that maintenance personnel, they could be deployed more effectively to worry about the unplanned downtime, and especially not having any knowledge prior to failure. This can be prevented.
I think this monitoring systems are easy to install when we talk about new ships. How about the ships that are already running? How complicated is it to maybe retrofit such a solution there?
Yeah, it's not very complicated to fit these, simply because IFM, we offer field-mounted devices, that allow the diagnostic units or the data acquisition unit to be fitted beside the machine, which means that there's less cable run. We have other options as well. We have some options where we can use wireless. But what needs to be taken into consideration is just having power available inside the machine. The sensors or the accelerometers, they can be fitted quite easily. It's not difficult. It's something that we are experienced in doing as well. So, yeah.
Okay, so it's easy to install, but how easy is it to analyze then the data, to interpret what the sensors are talking to us?
We make it easy by simplifying, the whole process. We have a dashboarding software that we use, called Moneo, where the data can be simplified to view. And when there is an issue, for example, if you detect that machinery condition has changed, we can alert the user very easily by a simple email, text message, or even a signal lamp, if you want to keep it as simple as that. We generally tend to make it simple, and that's the aim.
Rizwan, thank you very much for these really interesting insights.
Thanks you, Philip.
Thanks for being here. The company H&H Engineering develops SCR systems that enable ships to significantly reduce their pollutant emissions. We were able to take a closer look at exactly how this works in Eemshaven in the Netherlands.
We are here now in Eemshaven on the Norwind Hurricane. This is a service commissioning operation vessel, and we are doing service maintenance on the windmills in the offshore windmill parks. The shipping company is named Norwind Offshore, and we have headquarters in Ålesund in Norway. And we have 5 vessels right now, all in operation, and we have 3 new builds that's coming quite soon. We have quite high standards, and it's a quite modern ship. We have a SCR system for dosing urea in the exhaust system to give a lower value of the NOx. That's a new thing for a new build ship, that they have to use it to lower the emission, and that's quite important thing. And we also try to keep the low fuel consumption as possible, to have a small emission as possible and a green operation.
Wir sind hier heute in Eemshaven in den Niederlanden und stehen vor dem Wind Supply Vessel Norwind Hurricane. Wir sind von der Firma H&H Engineering and Service, ein kleines Ingenieurbüro, spezialisiert auf die Entwicklung von SCR-Systemen. SCR-Systeme sind Abgasnachbehandlungssysteme. Wir reduzieren die Stickoxide aus den Abgasen von den Motoren. Die Dieselmotoren der Schiffe sind nicht dafür ausgelegt, die Stickoxidemissionen innermotorisch einzuhalten, sondern die Abgasnachbehandlung muss außermotorisch erfolgen. Die Norwind Hurricane ist in einer sogenannten Emission Controlled Area eingesetzt. Das bedeutet, die Stickoxidemissionen sind stark reglementiert und müssen daher eingehalten werden. Wir nutzen wie in der Automobilbranche eine Harnstoffeinspritzung. Der Harnstoff wird im Abgasstrom zu Ammoniak umgewandelt. Dieser Ammoniak reagiert dann auf der katalytischen Oberfläche mit den Stickoxiden zu molekularem Stickstoff und Wasser. Wir müssen den Harnstoff sehr präzise von der Menge her eindüsen. Das heißt, wir wollen einerseits die strengen NOx-Richtlinien einhalten, auf der anderen Seite aber keinen Ammoniakschlupf generieren. Den Ammoniakschlupf gilt es zu vermeiden, denn Ammoniak ist ähnlich schädlich wie die Stickoxide. Wir nutzen die Drucktransmitter von IFM, den Durchflussmesser und den Strömungswächter für die Druckluft. Die Vorteile der Produkte von IFM sind die Zuverlässigkeit, die kleine Bauform und die Messgenauigkeit. Wir nutzen die IFM-Sensorik auf unserer Dosiereinheit. Dort messen und überprüfen wir die Harnstoffdrücke, die Luftdrücke, als auch die Durchflüsse von Harnstoff und Druckluft. An der Zusammenarbeit mit IFM schätzen wir vor allem den guten Kundenservice, die hohe Produktverfügbarkeit und das gute Branchenverständnis.
And we are back in the engine room now, and I would like to welcome Jürgen Müller, from Managing Director from H&H Engineering. Welcome, Mr. Müller. Thanks for being here today.
Thank you for having me.
So, Mr. Müller, we've learned in the video already that your solution, which you can also see here, reduces the emissions of ship engines. So is this primarily the goal, to help the global fleet to run more environmentally friendly?
Yes, that's one part of the global solution, so to say. The shipping industry realized that they have to do something to become more environmental friendly. The IMO, the International Maritime Organization, set up clear goals. That's the legal international framework to become CO2 neutral by 2050.
Okay.
Beside the IMO, the international rules, we also see local initiatives like the Norwegian NOx Fall. That is basically a tax on NOx emissions.
Yeah.
So these are main motivators to install such technology.
From the automotive industry, we know that there are emission goals that have to be achieved. Is this similarly to the shipping industry?
No, the automotive has a different approach. In the shipping sector, it's more on efficiency measures. So they want to increase the efficiency of a vessel to reduce fuel consumption, which reduces emissions. Of course, there's different consumption on a vessel compared to a passenger car. So this is a very, very big motivation also to save fuel. The shipping industry comes along with a lot of indexes, EEDI, EEXI, CII. All is based to reduce the carbon output, the CO2 output per transport work. Additionally to that, the shipping in Europe is under the umbrella of the ETS, the European Trade System, where the ships have to buy CO2 allowance per transport work.
Okay. Also in the automotive industry, e-fuels are a big topic. How about this in the shipping industry?
Yes, it's a very hot topic, actually. E-fuels is the buzzword because it's CO2 neutral.
Yeah.
What's not on the table in this discussion right now is, of course, the e-fuels, they are very dangerous, actually. There is more technology needed to handle the e-fuels, to store them. It's toxic, it's explosive, and it's really light to ignite. Secondly, e-fuels have a lower energy density than ordinary diesel. So comparing that, a fuel tank must be about 2 to 3 times larger than a diesel tank. So we will lose passenger or cargo capacity in some way. And then the e-fuels also come along with emissions. They are CO2 neutral when they are produced green. Right now it's gray or blue in best case. But especially ammonia, they come with a very high NOx output, also methanol, depending on the ignition technology. So you will need to deploy SCR systems again to comply with the actual rules.
So coming back to your solution, how much pollution emissions can we reduce by such a solution?
Well, we reduce around about 90%, 90 to 95% in the marine engines. It is a lot. Older ships with key laying date prior 2010, 2015, they emit between 8 and 12 gram per kilowatt hour. That's the unit of NOx emissions in the marine. And we go below 2 gram per kilowatt hour with that. So on the Norwind Hurricane, when we calculate that with an average operation profile, and that means 50% engine power for 4,000 operation hours per year, that will come along with emissions about 80 tons per year without SCR technology. With SCR technology, we are below 10 tons per year.
Wow.
That's quite a number.
Can you tell maybe a bit about the return on invest? Because, of course, we have to invest in such a solution. Is there a calculated outcome when you say it makes sense?
I think we can differentiate in 2 ROEs.
Okay.
The first one is I would like to go back on the emissions that we reduce for the society.
Okay.
Because NOx emissions come with the social costs, costs for the society by acid rain, ground level ozone. The studies that are available in the public domain from EU or USA EPA, they say about 10,000 euro per ton emissions of NOx. So on the Norwind Hurricane, we can save about 700,000 euro annually for society.
And only for this ship.
Only for this ship. And NOx can travel long ways. So it's not out of sight, out of mind.
Yeah.
When the ship is at sea, the NOx will be carried on land and will affect our health also on land. The second return on invest is about the vessel charter or reselling value.
Yeah.
So the operation profile will be wider. It's coming more and more emission control areas. We have US coast, Norway, Norwegian Sea, North Sea, Baltic Sea, and Mediterranean is in discussion. So you get a better chance to get a charter. But how the vessel value itself will increase, there's too little empirical data right now.
Okay. When we talk about $700,000 cost reducing for social environment, this is only for one ship. When we talk about the hundreds, thousands of ships that are underway on the oceans globally, that is a huge cost that can be saved.
It is an investment in the future, definitely. Yeah.
And is there an age limit where you can say it makes sense to install such a SCR system, or it doesn't make sense anymore?
No, not really by the age of the ship. We are limited by physical and chemical limits, so to say. We need a certain temperature. It is a chemical reaction. We don't filter it out mechanically. So there is no limit by age. It's space and chemical and physical limits.
Okay. So let's have a closer look at the SCR solution. I see lots of automation technologies there. What requirements do these products have to fulfill to be able to run in such a solution?
With the rule set of the IMO, there are strict limits how to achieve NOx emissions within the limits. So the certification is quite conservative as the whole industry. Automation can help to make the certification easier, more smooth, and that will in the end, I think so, leverage the acceptance of that installations. And that will also leverage the installation on older ships. So we can nowadays, with the help of this automation, measure what's going in, what's coming out, and that is all that counts. We don't need a reference certification as it is today.
Yeah, perfect. And I also see there's a lot of IO-Link technology in it. Is this a must-have, or is it just a choice?
It is a choice because we think it's somehow also the future in the shipping. It's well acknowledged on stationary industries. There is more and more initiatives coming up to standardize the maritime environment, electrical environment. The VDMA, the German branch of CIMAC, has set up a program to standardize interfaces between groups on ships, like ballast water treatment, exhaust emissions, engine management. So you have fixed interface and you can exchange supplier A to B, and you have the same interface and language on board, which makes efficient and easy shipbuilding.
So last question, maybe let's have a look into the future. You already said there is a higher demand for greener shipping. Would you say this will be increasing in the coming years?
Yes, definitely. We see it already right now in our, let's say, order book. There is more and more orders that are running up front the IMO regulation, because the consumers, the big retailers, they demand as low as possible emissions from their transportation, which is in the ESG reporting, scope 2, scope 3, all that should be lowered. Also the oil and gas industry, the big drilling companies, they only charter vessels that are equipped with such technology.
Okay.
So there is a trend that goes ahead of the international regulation, definitely.
Okay. Mr. Müller, thanks once again for being here today, and thanks for these interesting insights.
My pleasure.
And that's it for today. I hope you enjoyed it as much as I did, and of course I hope you will be with us next time. Until then, take care, see you soon, and bye.